Hey everybody, there was a request for me to make a short video based on kind of the work that I had done in class about the parallel circuits. So I'm going to do that. It'll be a bit abbreviated. I hope from what I did in class, it was a little bit lengthier than I would have wanted. But the big deal here is that we're talking about how to ensure that your circuits work well and don't blow out your lights. So in terms of the circuit diagrams that we're looking at, I originally drew this outside light circuit a couple days ago, which had a 9-volt battery connected to this light bulb, which remember is kind of rated at 2 ohms. If you look at it, they're not all exactly 2 ohms, but they're close to that, right? And it's maximum amount of voltage that can be passed through these light bulbs. Uh, it varies a little bit, but it's situated primarily around 2 volts. At least that's what it's rated as. Like if you buy these light bulbs, they say it's a 2 volt light bulb. And if you were to pass 9 volts of electricity through this light bulb, it would be too much and it would burn out the light bulb. So we added in a 5 ohm resistor over here on the side in order to go ahead and make this whole thing work. So that was the outside light. One of the rooms is going to need a parallel circuit in order to make this whole thing happen. And so in a parallel circuit, remember, you need multiple paths for the electricity to flow. And that's what I've drawn here, where I have my battery down below here, and I have a spot where some of the current is going to flow this way and some of the current is going to flow this way instead. And so that in and of itself means that it is a parallel circuit. So if I put in 2 light bulbs, right, then we end up with 2 different paths for the electricity to flow. In this case here, though, if I was to ask the question, are these light bulbs sustainable? Like, are they going to work without blowing out? Well, I know that down here, this is a 9-volt light bulb. If I was to connect in here and there, that light bulb is a 9-volt light bulb. And if I color code this circuit, you'll notice that in the color coding process, that this 9 volts, right, translates to the outsides of either one of these 2 light bulbs. Because the way you color code is the positive end of the battery is a high electrical pressure, and any wires that are directly connected to it then also become that high electrical pressure, only stopping when they get to a component, in this case a light bulb, which means that the voltage across each of these light bulbs, just like across the battery, goes from red to blue, which means it's also 9 volts, and this one is also 9 volts, which means that each of these 2 light bulbs here has a 9 volt across it, which is too much. And if turned on, they'll burn out, right? It's not going to work for us. So we need some mechanism to reduce the amount of voltage on the light bulbs. And in order to do that, I've included some resistors in your kit. I included 2 5 ohm resistors. So once those resistors are in place, the question is, where do you put them in order to make these light bulbs work? Now, one of those resistors is already needed to be used for the outside light circuit in order to make sure that we don't blow out that one. So now I've got one resistor left. I could hook up that resistor, to one of these paths here, maybe, and that would reduce the amount of current through here, and it would take up some of the voltage, so that you would end up with less in that particular case. But then electricity takes the path of least resistance, and so you'd have more electricity flowing through this one, and this light bulb would be out, right? So I need to put that resistor somewhere to be able to slow down the flow, and I can actually put this resistor right in here. Now, it turns out that I could have put it over here and it would have been exactly the same process. It actually doesn't matter as long as it's not after the split right here. It's okay. Well, it's not within the split, because I suppose you could think of this as after if you'd like, but either side, it has the same purpose. And if I go ahead and color code this now, what you'll notice is that this whole side, oops, I'm drawing with the wrong color. Let's see if we can make it. This whole side over here is the low electrical pressure, right? But now I've got this new resistor in there, which means that when I'm color coding the other side of the circuit, this is high electrical pressure. But when we get to a component, we then have to change colors. And so maybe we choose to change down to a green or maybe an orange in this category, which means that even though this voltage here is 9 volts, the voltage here, on the other hand, is not going to be 9 volts because this goes from a green to a blue as opposed to from a red to a blue. Same thing here, same green to blue, but now it is not red to blue. So we don't know what the voltage is there, but it's definitely going to be less than 9 volts. Same thing is true over here. This one over here goes from red to green, and we don't know what the voltage is there either, but it is going to be less than 9 volts. So in order to figure out the voltage across these light bulbs, here's what I'm going to do. I'm going to go ahead and figure out what the voltage is across this resistor here, and that's going to allow me to know kind of what voltage is left for these resistors there. I could just do it straight for those resistors, but what I really want to find out is what is the current that flows through the circuit as a whole. So here's what I have to do. I'm going to use this volts equals current times resistance, which is Ohm's law. And I'm going to use Ohm's law on some different pieces in the circuit. One thing to know is that in order to use Ohm's law, I can use it on a particular component, or I can use it on the circuit as a whole. This particular circuit is made up of things that are in parallel and things that are in series to those things that are in parallel. So these two light bulbs on this side are in parallel versus this is in series with those two things that are in parallel. So what I'm going to do is I'm going to redraw this circle a little bit where these two kind of resistors that are in parallel, let's find out what the total resistance of those are, and then we can kind of shorten it up a little bit. So my circuit, on the other hand, can be redrawn where instead of having kind of two light bulbs in parallel up above, those are going to act like a single resistor up here. Now remember that light bulbs have resistance, and each of those light bulbs has a resistance of somewhere close to 2 ohms. They might not be exactly 2 ohms, but close to it, which means that how do I add those two resistances if they're in parallel? I cannot just call this 4 ohms over here if we're kind of saying, well, what's the total resistance of those two? That's not how we add resistances in parallel. What we need to do is add them so that it's 1 over R total, or R effective, depending how you want to say it. And this is 1 over R1 plus 1 over R2, right? Where these two are in the parallel part. So 1 is this R1 maybe, and this is R2 here. But they each have 2 ohms of resistance. So I can go ahead and write those in. So 1 over R total is equal to 1 over 2 ohms plus 1 over 2 ohms. And if I add these two things up, right, I end up now, I already have a common denominator, so I have 2 over 2 ohms. And when I flip both sides, what I walk away with is that my total resistance now is equal to 1 ohm. So these two resistors combined up here, these two light bulbs, have a total resistance of 1 ohm. So this now becomes a 1 ohm kind of resistance up there. This was a 5 ohm resistor putting into the circuit. So now at this point in time, you can say, great, we know about the parallel parts. And when we now add this in series, this is easy. My total resistance in series is just kind of R1 plus R2 here, right? Where R1 in this category is this first resistor here, or this resistor over here, right? And then my R2 is the one that's up on top. So I now have 5 ohms plus 1 ohm, which is equal to a total of 6 ohms. So the total amount of resistance in the whole circuit is 6 ohms, and that determines what the current is that flows through this resistor. So how do I find the current that flows through that resistor? It's pretty easy. I would use Ohm's law, but now solved for current, which is now voltage over resistance, where my total flow, right, is 9 volts. and my resistance is 6 ohms. And so my overall current flowing through this is 1.5, oops, not volts, amps. So my current that flows through this outer loop here, kind of through that and comes back across this way, that's 1.5 amps. It splits up when it gets to here. There's less going that way and less going that way. But nonetheless, it's 1.5 on the big category out there, which means that through this resistor right over here, this one, it's 1.5 amps. And so let's go ahead and find out what the voltage is through that resistor. And the easy way to do that is, again, using Ohm's law, only this time round, I now know that it's 1.5 amps through there, and the resistance of that particular resistor is 5 ohms, because I'm putting that in. So if I multiply these two things together, I get 7.5 volts. So this voltage here, right, is 7.5 volts. In total, I had originally 9 volts to work with, but 7.5 volts of that is taken away. You can think about pretzels, right, being handed out. So they're taking away 7.5 volts of the original 9 volts that are coming into it. So now, as those kind of charges flow through the next piece, there's only 1.5 volts left to hand over, and they're going to hand it all over in each case. So that would be 1.5 volts gets handed over there before they end up at the bottom of the battery back down at kind of 0 volts. And so this is 1.5 volts there, right? Remembering that in total, if you think about the drops, the voltage drops, they have to equal 0 in the end, or you can think about them as subtracting from the 9 and equaling 0. So 7.5 plus 1.5 is 0 when you think about subtracting from the 9. What's good about this is that both of these light bulbs here now are going to light up. And they're going to light up because they are not experiencing, right, any sort of a problem with too much voltage. They're not going to burn out. So hopefully that's a helpful tool to you to understand kind of how this whole thing works. I did a number of steps in this process in order to get there. And what I was really sorting out was to be able to say, okay, what happens to these light bulbs if I was to put in a resistor there? What is the voltage across those light bulbs? And by the way, the higher this resistor here, is, if it was a 10 ohm resistor or a 15 ohm resistor, the less voltage that would be across those light bulbs, and they would be dimmer in the process. So hopefully that was helpful, and we'll see you in the next one. All right, take care. Bye-bye.